The washer method is used whenever your representative rectangle is not sitting on the axis of revolution. Now, if this came all the way down and I were to rotate it, I would have this solid disk. All right, so the volume of the disk that is solid is pi times the integral from A to B of, now how tall is my representative rectangle? It's of course big R of x. So this is the solid, S-O-L-I-D, okay, solid disk. Now, from there, you're going to need to subtract off the volume of this hole. And the volume of the hole is defined by little r. So the volume of the hole is going to be pi times the integral from a to b of little r of x squared dx. So suppose I have this representative little space here from a to b. Big R is a distance from my axis of rotation to the furthest most point of the rectangle. Little r is the radius of the hole, and you can think of it that way. This is the radius of the hole. This is the radius of what the solid disk would be. Then the solid of revolution is, and we just write it this way, pi times the integral from a to b of big R of x squared, which is the disk, minus little r of x squared, which is the whole part. Let's try one. Find the volume of the solid form by revolving the region bound by y is the square root of x and y is x squared about the x-axis. Now, you can see we're going to need to use the washer method because the entire rectangle does not rest on the axis of rotation. So the first thing you need to do is identify big R and little r. So you put in your representative rectangle and you need to show me delta x. Because remember, that tells me everything now needs to be an x. As soon as I do that, I need to find a and b. I know it's on the diagram, but to find a and b, I set the square root of x equal to x squared. So I'm going to square both sides. X is x to the fourth. I want you to factor, don't divide out. So x to the fourth minus x is x times x cubed minus 1. And where is this 0 when x is 0 and x is 1? So this is my a and b. Next, you need to clearly identify what big R and little r are. Remember, big R is from the axis of rotation to the top of your representative rectangle. So big R of x is the square root of x. Little r is from the bottom of the rectangle to the axis of rotation. So little r of x is x squared. Now I do want you to write what your differential volume is going to be. So delta V is going to be pi times, now what's the area of the solid, I'm going to put a parentheses here, the solid disk is going to be big R of x squared minus little r of x squared and delta x. So this tells me the volume is equal to the integral from 0 to 1, and I'm going to put the pi on the outside, of the square root of x squared minus x squared squared dx. So remember, all of this needs to translate on down. All right, so this becomes the integral of pi, the integral from 0 to 1 of x minus x to the fourth dx. So this is pi, a little space down here, times x squared over 2 minus x to the fifth over 5 evaluated at 0 and 1. So this is pi times 1/2 times 1 squared minus 0 squared minus 1/5 times 1 to the 5th minus 0 to the 5th. And this becomes 3 pi over 10.